Hello and welcome. I'm Bill Wake. We're here working on a test package. The idea is a new test framework that one part is to know parameterized tests, and I think we've pretty well done that. The second is to know kind of standard arithmetic or algebraic laws, and we've been working our way through those. So today we'll focus on associativity and identity. We've already done commutative. Associative is basically the fact that parentheses, you can leave them out. They don't, if you operate on the parenthesized first and then the A op B op C, or you can do A op B and then do op C, and it all works out the same. So parentheses don't count. And then the identity idea is think of 0 with arithmetic. If you do plus, I use star down here for an operator. So let's take 1 in multiplication. A left identity says if you take 1 times any item, you get that item back. And a right identity says if you take any item times 1, you get the item back. If you're a full identity, you're basically both left and right. In arithmetic, 1 for star and 0 for plus, they're both full identities. I don't know if people say full, but they are identities. And so I want to get those two in because they're these three are kind of the big three, I think, just that tend to pop up. I have a bunch of other laws I've dug up, distributive, logical laws, De Morgan's law, idempotency, evens and odds. Oops, formatting's a little off there. Evens and odds are things like signs when you're multiplying, or XOR and logic, kind of testing not equal. You kind of alternate back and forth. And some others. Okay, I don't want to emphasize those too much because what I really want to do is get these done and then move over into an old application and try this test framework out and make sure it's heading in a useful direction. Okay, rather than going out and implementing 15 more laws, I think these 3 would be enough. Okay, so let's take associativity. Now we have transitivity, which A greater than B, B greater than C implies A greater than C kind of thing. I think we'll want to make associativity look a lot like that. So let's do that. Let's test associativity. And I think we're going to say check property dot associative. Operator is plus, and then the values, let's take 2, 1, 3. We're basically checking 2 plus 1 plus 3 equals 2 plus 1 plus 3. Okay, and they both should be 6. Okay. Now, associative doesn't exist, so that's messing things up. All right, but let's see. I think, yeah, that should do it. Let's get this compiling. Okay, here's transitive. Associative, well, we need a new case now. Let's just return false, and we can go from there. That looks more complicated than I thought, but okay, let's return Boolean expression. Oh, I had to return a function? Okay. Okay. What just happened? Did I lose a print? Sure enough. Okay. Let's make sure that test fails like it should. Oh. Int, expert type, int bool. Oh, yeah, Yeah, that is different, isn't it? Well, that's more like the other one. With ternary predicate, I don't think we have ternary property. No. Okay, let's do that. Associative. Okay, I'm just trying to return a false value. Let's take the associative out of here because that's not going to work. And then, unfortunately, just like we have a binary property check property, we need a ternary check property. What's the difference between these two? Oh, all pairs. Okay. We're not doing all pairs yet. All right, check property, binary property. Let's do ternary property of T escaping binary op ABC or AB, we need C. Okay, AB, C comma up. Okay. This should fail. I keep saying we're going to not need more check property function definitions, but we keep needing them. Well, wait. Associative 2 plus 1. Wait. Did that really run? Okay, I'm puzzled. Check associative. Did I return false? Well, guess we'll make sure we're getting here. No, property. Yeah, okay. Sure enough. Okay. Let's step out. What? Assert equals. Oh, wait. We want to assert. We want to fail. Okay. Can't get my rate failure. That's more like it. Okay, property associative does not hold for 213. Well, it should because we didn't really check it. Okay, so associative property. Well, if we go back to the definition, that's op of A, op BC equals op of op AB and C. Um, get this on one line. Excuse me. Okay, A with BC is the same as AB with C. That's this. Okay. Now that should pass. Okay, and then we want the flip case of check failure. Let's say succeeds and just associative fails. One minus three. 3 minus 4 is minus 1. 1 minus minus 1 is 1, so 2. Or 1 minus 3 is minus 2. Minus 4 is minus 6. Okay, so I certainly expect that to fail. And, well, it should fail this, but that should catch it and say it's okay, and it should work. Okay, so property does not hold for 1, 3, and 4. Okay, we can't really say what the operator is, unfortunately, so, but I think that's okay. 1 minus 3, well, 3 minus 4 is minus 1. 1 minus minus 1 is 2. 1 minus 3 is minus 2. Minus 4 is minus 6. Okay, so they are different. All right. Well, let's take what we got. Check associativity. Why that? Well, these all look like my files, right? Wait. This is. Let's cancel that. eg.swift. There is no capital eg.swift. Okay. Huh. Okay, let's take these both out. Okay. That apparently checks them in anyway. Okay. Can I? Well, let me cancel this. Keep this. Okay. I don't see our ternary property. Okay, so let's. There it is. Now is this okay? Probably should have run tests there. Okay. All right. Well, that's associativity. Now, let's deal with this left identity. Okay, we'll start with a test. We want left identity on plus, and then the identity is 0 and 3. Okay. Binary property of int. Well, none of them match it, so it doesn't really tell you. Is it binary? I guess it is. Well, let's flip it just for testing purposes. Okay. Should fail. Up. What did I do again? Binary predicate. Zero should be a left identity for plus and 3. Well, let's make sure we're getting here. I don't know why I'm having the same problem again. A little foggy brained, I guess. Yeah, didn't get there. Where's check property? Binary property. Oh, same problem I've always had. Let's make this assert fail. just fail. Property does not hold for A and B. Okay. Okay, for left-handed hold for 0 and 3. Good. Let's go back up here. Equals. Okay. Oops, this should be expected failure. This is going to be right. Okay. Why is that ambiguous? Better property if it has no member. Oh, that will do it. This one should pass. These two should fail. Well, this one doesn't fail because I flipped this line, but not hold. Okay, so let's. This is op of x e. Okay. Okay, and now identity. Well, okay, let's add identity. I guess I'll do it in the other order. Okay. I think that should pass. Okay, good. Alrighty. So we got identity. Okay, so, well, let me find my to-do list. Check equivalence relationship. No, I think we're starting with associativity. Check associativity. We did that one. Check identity laws. Okay, and then now, gosh, do I need another variation? I do. Okay. Well, let's make our test. All right, want to pass a list? Well, let's do 0, 1, 9, minus 2, minus 17. Okay. Need to find the all pairs version. Right, so binary property, we really have a ternary property. Associative, so we need another variation of this. All right, so check property. Binary, let's make this ternary. Oh dear. Okay. Skipping binary out values. Okay. Problem is we need an all triples now. Yeah. All triples values and closure returns a triple. Okay, and okay, and this should be all triples. And let's make a mistake. It should be $2. I don't know if it'll complain. Yeah. Does that break it? It isn't really, is it? Okay, the problem is I'm getting triples, ABC, ABC, ABC. I'm using ABB, but the associative law holds for ABB just as well as it does ABC. So I'm not really testing all my combinations. So that works, but all right, let's make a new test. All right, let's test the negative case. This is succeed, and this is fail, and my function is going to be different. I'm going to say let op equals A, B, C, no. Yeah, A, B, C, N. Well, no, I want a binary property, don't I? It's the plus operator correspondence. Okay, if I had a plus where what's a non-associative? I only want to catch it if it gives me ABB. Well, if A equals B, return A plus B, else return A. And that's A plus B. Let's see. A plus B plus A plus B. When they're equal, that's gonna act weird. I think I think this is gonna fail. Man. Ambiguous use. Grr. Just getting further and further away, aren't I? Was never used. No, that's not right. Um, why is that ambiguous? Okay, yes. Those fail. Okay. But if I. Where's my C? Well, those should fail. Okay. Wait, the wrong ones. Okay. Minus 202. So minus 2 plus 0 plus 2. A equals B. Minus 2 plus 0 plus minus 2. Minus 2 plus 0. Wait, 0 plus minus 2 is minus 2. Minus 2 plus minus 2 is minus 4. Okay. Minus 2 plus 0 is minus 2. Oh, plus minus 2 is just going to be minus 2. Yes, that should fail. Okay, so now we got to check expect failure. Okay, They should all pass now. Okay. Let's check that in. We check associativity for lists of values. Now, I'm gonna say identity's a little weird. Because we need to know what the identity is. So, all right, this is triples actually. Okay, now identity, let's just check. Well, I don't think it really matters. Okay, so let's check identity pairs succeeds. And we're going to do this. And this is with the array of values. -3, -1, 0, 1, 7. Right, so there's no matching check property. Oh, golly. Maybe I got to call this one out. Check identity property. Let's add one up here. And that's a binary operator. Operator A, B. Well, now we need identity. I don't know. Sometimes I call it unit. And this is array values of array of T. Okay. And, well, that's not going to work as is, I don't think. Identity property. Well, yeah. Okay. So we just need all values. For each. Is that what we're doing down here? Yeah, so we'll go through each value and we'll check property, the property, the operator, the unit, and $0, the value. And I guess we can pass file. Line. Okay. And this should pass. All right, and then let's get one that's not. 0 is an identity for minus. So, well, let's just take 1 again. That should fail for a bunch of these. Expect failure. Expect failure. Okay. And this should pass because it fails. 1 and minus 1. 1 plus minus 1 should equal minus 1, and it does not. Okay. Alrighty. Okay, I think let's make sure everybody's happy. And identity with all values. Okay. All right. I think I've got what I'm hoping is enough. Okay. So I'm gonna, what am I gonna do? I gotta package this up somehow. I think well, I know I gotta label it. All right. Let's tag it 0.0.1. Now this, we've pushed it to GitHub. It's become a test spike. Let's make sure it's in there. Yeah, identity and so on. Okay. Is that all I gotta do? I guess I'm gonna have to research it again. Swift create package. Maybe I just have to reference that. Okay. Let's go back here. I'm gonna open up an old project. Sort tables. That's too old. Should be a basic interpreter here somewhere. Bassi, yeah. Okay. This is our basic interpreter. Okay, Lexer parser interpreter. Yep. All right, and then it's got a package dependency. Let's see if I can add. Oh, how do I add a dependency? Add packages, yes. But can I get to it? GitHub. Let me add one. Is this? I don't think I want to do that. Add package collection. Is that it? Okay, maybe it's not a collection, maybe. Okay, let's get on that. I didn't have this much trouble, I don't think. Become a get. Okay, let's try that. This one's called test spike. Okay. All right, tell you what, let's just take a break, 3 or 4 minutes, and we'll come back and see if we can straighten this package thing out. Okay, welcome back. I think I've got the deal here. I put this in, which matches the GitHub, and we'll just try and add it. Okay, that seems good. Apparently I haven't done anything on the README. Let's take a look at that. Open README. It's true. Okay. Okay, could not be resolved. Package.swift doesn't exist. Let's figure out what's going on there. ls ptest. Well, that certainly exists. Maybe I gotta go in a level. So ptest package. Well, no, that's the right thing there. Okay, let's try again. Dependency row branch, I guess. Up to next major version. Bassi. Maybe this package is not formed right. Updating from pcombo. Test spike. Updating from test spike. Failed to resolve dependencies. No version of attached spike matches 0.0.1. Well, I feel like it does match it. Let's see. I don't know why I can't specify this one. Range of versions. I think I'm finding out that README is different in these two. I don't know. Minimum. Okay. No versions of test spike match. Oh, I didn't push the label. Okay, let's go over here. Oh, yeah. See if we can see that on GitHub. No tag. I feel like I'm missing something. Okay, that's better. All right, now let's try again. I can live without README, but package.swift does not exist in file system. I think, let's see how we've organized pcombo. I don't know, I'm still not smooth when I create a git package. I mean, I do git init on the GitHub side, and then try and build the new project on the Xcode side. I think I'm just not smooth. Okay, where's pcombo? And sources. Sources is in the top level directory with all this. Okay, so that is not the organization we have. Okay, let's cancel this. Hide that for a minute. let's see what we have. Sources ptest package, readme package, and sources at the same level. Readme package sources, but I don't know if I have them at the same level. Where's this? Oh, I have two readmes. I think I want to go up a level. Well, I don't know if I can do this. What were they? What sources? Pcombo. Tests. I guess this needs to go up a level. I don't know if I can do this. No, somebody's not happy. Source tile. Just package to be under source. Path property and package.swift. Okay. Wait a minute. Okay, pcombo has sources slash pcombo. Oh, so I'm going to revert this. But I think what happens, okay, up here I got package readme and then lsp ls sources slash star. I have eg and then ptest package under there. ptest package.swift. What's that thing? ptest package.swift. Well, that's nothing I want. Okay, delete unused. This is now let's go back here. package, GitHub, test spike, branch main. That's fine for now. Project bassi. Let's see what it says. I think he's going to say he's got no packages file, and that's a problem. Package.swift cannot be executed. Accessed. In testspike.get. All right, let's see test spike. .get. We have no package. .swift. Okay, that's interesting. ls. Okay, now why is package.swift not here? Okay. Name ptest package, library, test package. That all looks good. Package.swift. Show files. Good test spike. I don't have a package.swift. Wait a minute. Wait just a minute. Okay. In test spike. Oh, cd dot. Is package.swift supposed to be up a level? Okay, ls dot dot. Is there p combo? Yes, he has package.swift up a level. Okay, so package.swift. No. Make sure I got the right one. That looks okay. Should show the moved file. Okay. Yeah, I could have done a get move, I guess. Get add dot. Get commit sim. Move package file. Push. Okay. Now, that guy's going to be a little out of date, but. Okay, back to bassi. Cancel. Try again. Well, that's more promising. Should be under source. For target ptest package should be located in our source ptest package. Yes. I agree. Whether that's enough. Okay, he's not happy. Source files for target ptest package should be located under sources/ptest package. Oh. Okay. I may be screwing up everything. Sources/ptest package. The problem is this is at the wrong level. Golly. Okay, we're in test spike. We have ptest package. Sources tests, that readme is not good. todo.txt is, I've been fighting the wrong version of this. This is what's going on. Okay, but can I relocate that? I don't know if I can relocate it, but I want to move it up a level. So let's open test package again. Nope, that was weird. Okay, let's try again. Open a project. Okay, we don't want bassi. We want test spike. Okay. No, something's weird. Ptest package. Move that to here. Move ptest package/test to here. Now what's in there? Readme and to do, which are also both wrong. More ptest/to do. Yes. Okay, so I think I can safely delete this. Okay. Let's try a rebuild. Ptest package. Build succeeded with this little message still there. Ptest package should be under test/ppackage tests, or custom tests can be set up. Let's try running. Source files for ptest packet. Oh, there it goes. Okay. Let's commit this. Rearrange packages. I may have to check twice. Yeah. I think that's getting rid of those files. Okay, let's build, run tests. Okay, I'm still getting this message. P test package test should be located under test / P test package tests. Tests should be under P test package tests. That looks perfectly right to me. He's certainly finding them. Okay. Any differences? No. Okay. Now, let's try again. Repository, test spike main branches, main current. Okay, now bassi, where are you? Okay, now you. Well, that's kind of promising. Let's update package. I'm going to clear this and rebuild. Compile fix 561 cannot be imported by 572. What? Module compiled 561 cannot be imported by a 572. Missing project package. And there's that error again. Okay, can we run it? Now, I think it may be that 561, where do we choose that stuff? 12.3. I mean, I'm running on 13.1 for my package, so maybe that's all it is. 6.1. I don't know where the Swift version is. Expression parser. Input tests. It seems like it's just so unsure about itself. A smarter man would have tested it again before bringing in this new package. Where would we say? The only one I can think of is that. That seems okay. Let's clear, clean, and rebuild. Bassi build, bassi API JSON. Swift module. Okay, let's, where's our window? So test spike. Well, he doesn't mention any in this. He says 5.7. Is that what that's complaining about? This module. I don't think there's any updates. Why? Test spike. I mean, there's tools version 5.7. Is that the complaint? P combo package 5.6. But that doesn't mean it shouldn't work with 5.7. Okay. And now bassi project info build settings. I was talking about his Mac OS. Okay. Info. Should I change this? Apparently, yes. Okay, let's try that again. Bassi.avi.json. Who are you? Okay, let's back it up. This guy changes. Hopefully the package goes away too. Good. Okay. Now let's run tests. I mean, my package is about the simplest thing you could have. All right, so it's either the compiler upgrade or something with our package is still not right. Okay, let's do clean test, clean build. Compiling from macOS 12.3. Why is that true? Deployment 13.1. Pretty normal. That's the target. Target bassi, but bassi tests are the ones that seem to really have the problem. Okay. Oh, I'm going to change that too, I guess. If there are any. Change them too. Okay, now try tests again. Okay. Let's see. We've updated to Mac OS 13.1. Okay, now go back here. Add a dependency. Recently used, test spike. We'll just take the latest because we're experimenting. That's okay. All right. And let's make sure everything still runs. And it does not. Okay, we now want undefined symbols, static string via CTF support. Found not found, bassi.app. Test assert equal file line static string. Let's see the bassi tests had an issue. Oh, they didn't find bassi because bassi's not there. You know, maybe I've got that project in the wrong place. Can I do an undo? No. Can I remove? Why can't I delete? I think I put the dependency on here. Oh no, is that? Let's do this. Let's try again. Which is recently used test spike, branch main, bassi. P-test package library, add to target. I think I want to do that. We'll build. Build failed. Okay. Library not found, bassi. Let's do a clean. Okay, and then this thing, yeah, that's been a Thorn forever. Okay, but it seems like maybe okay now. Okay, so we add test spike library. Okay, now the point of all this is that theoretically working on a compiler is going to be as much as any place else where we would find examples that need those algebraic laws. These are helpers. Okay. Rebel test. Okay, so can we find any minus number 3 type is subtracting two numbers, adding numbers is float. Yeah. Okay, so lex or tests, we check either token string, unquoted string. Okay. So I'm just looking for something that sounds like associative or commutative. um, if it's not, I'm going to drop it. I mean, it just seemed like a good idea, but nobody really cares. And I'm a little afraid that's true because looking at this so far, I haven't seen anything that sounds like it wants that. Okay. Now, it may be that in expressions, like the type of something. Well, yeah. So can I characterize the types? I mean, that's like the type of an arithmetic operator is number. If its arguments are number, its value is number. So it's kind of a projection on the operator. Um, there's just not enough there. These are all the statements, but I don't think of them as being associative per se. You probably could think of them that way if you did some sort of real semantics kind of thing. Now this. Okay. Yeah, nothing here sounds associative to me. Well, maybe the interpreter tests. Let's see, rebel. I mean, I feel like these tests should line up a little more with the folder structure up here, but okay, let's see what we got. Interpreter tests. Expression. Excuse me. You know what? I don't think so. Data read, no. For next. Not really. On market print, no. Okay. I don't think I see anything that really screams out to me that it wants to do this. Now, the parameterized test aspect might be a little more interesting. Let's go to EG. Putting examples with inputs and outputs. Do I have enough of those to be interesting? Well, that's a pretty complicated expression in our input. Our output is dot number. Hard to sell it for just one thing. Well, you could do it more for this. You take a program and you expect some results. And this one is logical operations on inputs. They won't read so great. But yeah, that probably would work. These are a little custom. This one's check program results. But I don't think the readability is going to go up substantially because the code that we're testing is so big relative to the rest of it. Check program results probably is good enough. I mean, I have needed multi-thing tests, so I don't dispute their usage utility. I just don't think they're going to help these too much. I mean, a little. Okay, so I'm going to take this package back out. Let's see, we do that up here. Package minus build and run. We saw 296 tests running in under a second. Nice and speedy anyway. Okay. Remove p test package. All right. Well, let's take another break. 3 minutes and come back and we'll decide what to do with our test spike. Hey, welcome back. All right. So I think what I want to do is kind of review the code we have and then make decisions about what we're keeping. Okay. So I guess we'll start here. This is just saying there's binary operators, and I haven't been consistent about using it, so that's kind of too bad. Do I need it here? I don't really. Let me move this down. Okay. Now, what we did was we identified different kinds of properties. There's binary ones. They basically take two arguments and then we do an assertion on them that gives a Boolean assertion. So commutative operator AB equals operator BA, left identity we did today, right identity, full identity. Okay. And corresponding to this, there's a check. And I don't know if... Yeah, check property, binary property. Okay. So that uses that property. This is what a user calls. They call check binary property. Give it an operator, give it a couple of values, since it's binary, and then they run the property. And if it works, then you return. If not, you fail. Now, have we been consistent on that? We had some inconsistency before. Fail, 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 fail. Okay, that's all good. All right, then... Well, then we had other kinds of properties. I don't think they work any differently. Just this ternary has more operator or operands. It needs 3 to make a comparison test. A of BC equals AB of C. Okay. And again, there's a check property extension that does ternary properties. Okay. And I don't think any of these are different. It's just we've got lots of combinations. We have binary properties that operate on closed values in a type. And then we have these predicates that operate and return a Boolean. And we can do a little bit different with that. Same thing, transitive. I mean, they're not terrible properties or anything. I don't think it's a bad way to do it, but we just didn't find usages for it, so I don't think it's worth keeping. Okay. But they work consistently. I mean, I think if we went and did the other properties, let's see if I can find, I guess they were in here. Okay. Left distributive. So these are two operator properties. So we would know we'd have to do a new check. PQ, not P or Q, has got 3 operators, BNQ, PQR, and only 2. Okay. Double negation, negative, negative 1 equals 1. De Morgan's law is another 2 operator one. Idempotent is binary, but if you do the same thing twice, you get the same result. Reflexive, you equal yourself. Evens and odds, pretty obscure. I mean, you get it for signs. You get it for, well, even plus even. Yeah, so addition in arithmetic, evens and odds. XOR is sort of a not equal in logical terms, and you flip consistently with that. Symmetric, anti-symmetric, transitive. So symmetric is if A equals B, B equals A. Okay. Also, less than or equal is symmetric. A less than or equal to B implies B less than or equal to A. No, it doesn't. No. Anti-symmetric. If A related to B and B related to A, then A equals B. So less than or equal corresponds to that. Transitive we did. Intransitive says if A relates to B and B relates to C and A does not relate to C, okay, then A does not relate to C. Intransitive, there's at least one. Antitransitive, they all are like that. And the classic example is rock, paper, scissors. If rock beats scissors, but paper beats rock, and then scissors beat paper, and it goes in a circle. Sometimes you get it in sports games. Team A beats B, B beats C, and C beats A. You know, it all kind of wraps around. But again, this one has a couple, three operators, two. Yeah, it's sorting, topological sort. So think of course prerequisites. You have to take calculus 1 before you take calculus 2, and French 2 comes after French 1. Okay, inverses, then you're getting into the real algebraic, abstract algebra stuff. Equivalence relation, monoid, group. Every element has an inverse. Okay. Yeah, I mean, there are monoids out there. That's not a bad thing to be. I just don't think I'm getting the leverage in the testing I want from this. Okay, so what did we change here? Oh, I moved that thing down. Okay, so didn't run tests. Okay, now I'm going to take out all this. Let's see, the pair stuff we might want to keep. Okay, let's see how this does. Bunch test should fail. Okay, let's go find the example tests. Okay, that's parameterized. Property tests are not going to work. Lots of property tests. Okay, now that's there. We lost our tests for all pairs. I don't know why I need equatable. I don't know why I need a closure. Well, it's a different thing, I guess. Yeah. Check is the parameterized. EG helps with the parameterized. EQ is just kind of an abbreviation for me. I don't know that I need to return false. Is this being used? Yeah. Okay, let's make sure test pass. Okay. And remove all algebraic identity helpers. Okay. Now, all pairs, all triples. Okay. I think they could be helpful, but I don't need equatable. I think I just want to spit out the values. Well, other languages have better facilities for this, I will say. I wish I had a yield statement. Excuse me. I don't know. So now I'm left with my EGs, my examples. Check the examples, a little helper function that isn't tested, and a all pairs and all triples that has some use but is not tested either. Okay. Let's test them. I feel like they're a little bit useful. This is just an abbreviation for XCT assert equals in effect. I don't know. Is that doing it? I'm going to drop it. Now, all pairs. Okay, let's add tests for these, and let's get the naming straight. This should be EG. Let's make it EG tests. Oops. EG test.swift. Run everything. Okay. Okay, so that is my check. The demo, yeah, okay. Let's check all pairs. Okay, and I think what I want it to be, let's see. Let's keep this going in here. Function test all pairs empty. So if I put array in A, B, C, and 0, 1, and nothing. Okay. Let's make this array of int. Will that work? Okay, I think that may be a question of this. I need values of two types. That, and it yields an array of T1, T2. Okay. And let's just return what? Return empty. Cannot find T2 in scope. That's really weird. Function T, oops. T1, T2. Expected and body of declaration. Yes, and well, you should. Okay. For lookup requires any conform to sequence. For lookup requires any goes to hashable to conform to sequence. I don't need hashable. For and loop requires, well, okay, how about I use my variables? Embarrassing. I don't care about that, but let's just do this. Oh, equatable has to be. Okay, let's do result.count equals 0. Well, that'll pass. Okay, yeah. Okay, so let result. Well, okay, let's write the test first. Okay, so all pairs is not empty. Let's take 0, 1, 2 against 3, 4. Okay, result.count should be 3 times 2. And I'm going to assert result sub 0 dot 0 should be 0. 0.1. If you remember, in a tuple, these are the accessors for the two elements. Should be 3. So it should be 0, 3, 0, 4. No, wait. 0, 0 should be 0, 3, 0, 4. No, 0, 0, 3. Okay, it's the first one. Then 0, 4. Inner one's varying the fastest. And then the last one, 5.0 should be 2. And 5.1 should be 4. Okay, that should completely fail. Now, it'd be nice if tuples would auto-synthesize an equals method when the two types are equatable. I don't know why it doesn't. That seems to be like a bare minimum kind of behavior to me, but I don't know. Result of T1, T2 equals nothing. Okay, result.append. And we need the tuple. Okay, now A and B are used. We're passing the tuples in. All should be happy. There we go. All right, and the test should run. But anyway, I don't know why they don't do the tuple one for you. It'd be very handy a lot of times, and I don't see any semantic reason you couldn't do it, since now it's disallowed. And it's got clean semantics, but okay. So that appears okay. All right. And then this one, we want the same kind of deal. T1, T2, T3. T1s. T2s. T3s. Okay, and it should yield an array of T1, T2, T3 tuples, which just aren't super fun to work with, but I think it works enough. Okay, so for A and T1s, B and T2s, 3s, okay, do nothing. And then just return empty count or empty list. All right. Well, I guess I didn't have much of a test for that. Test all triples empty. Empty and 0, 2. All triples of ABC, nothing, and 0, 2. I don't know if he's going to like that. I probably should do the same thing I did up there. An empty int array. Okay. And the count should be 0. Well, we always return empty lists, so I think that's okay. All right. And then the triple's not empty. It's going to look similar to this one. Let's make it a string, an obvious string. Okay, so 0, 0, the count is 3 times 1 times 2, which is 6. Okay, entry 0 dot 0 should be 0. 1 should be abacus. And results of 0 dot 2 should be 0. And then these, well, 1 is always abacus. 2 and 4. Should fail pretty thoroughly. An access error and a couple wrong answers. Yeah. Okay. And we're going to do the same kind of thing here. Should pass. Okay. Oh, That's a 3. 0 abacus 3, and the last one is 2 abacus 4. Yes. Okay. All pairs, all triples. Okay, so we gave that. All right. Tests for all pairs and all triples. Okay, that's that. Okay, so what we don't have is a good README. Let's address that. Well, what do I say? No, I forget if you have to say input and output as. Yes, you do. Okay. Now, does it do file? It just does line. Self-dot line should be uint as well. Okay. I forget my markdown is triple quote on it. Cheat sheet is what I want. I guess. Oh, back quotes. Okay. Okay. Still hanging it. Oops. Now, I thought pound line had to be uint, and now it's not. I don't remember what they call those things. I don't know what's going to trigger it. Getting all the same ones. No. There it is. Yeah, it kind of should be uint. And I think we need to capture that thing as well. Test string. I guess we need a test that doesn't pass. Okay, func testers. Input -1. This is the sum of sums. Let's okay, I don't need these others. Okay, this test should fail. The message should be in the right place on this line 34. Okay, I think that convinces me we need the file. Trying to get this to fail and fail in a nice kind of looking way. I may be off on this. I don't know. 34. Well, that's the right line number, so maybe it's okay. And this isn't expected. What's it? XCT expect failure. Okay. Back to this. And I'm going to change the name of this to EG test. I think we're going to have to do some renaming. Maybe this is capital EG test. Maybe I should put this below this. No, that is part of that, isn't it? All right, let's get the triples in here. I don't know if this is the best thing since sliced bread or anything, but I think once in a while you'll appreciate it. Okay. You can take this and pipe it through something that would make these work. Create your own examples, basically. The input and output types are generic. You can use tools to work with more than one value. And maybe I'll make this example be part of the real thing. Okay, and let's see this. Open read. I've got a more markdown editor. Okay. Excuse me. Let's see. Do we have to do? Okay, so let's see. We did these two things. Then I'm gonna spend a few minutes wrapping up here. I guess run a little long. We tested our package with bassi, the basic interpreter, and found that the algebraic laws just didn't help much. Excuse me. Then did we do this? No. Then what we did was we dropped all the algebraic property tests checks. And now we're packaging the remaining EG work. Sorry again. Can't quite shake this cold. Okay, so I think we have dropped all that. And then I think we're going to try and rename this to EG test and ship it. Well, let's say release it. I guess that means I should put a license in here somewhere. All right, so we'll do that bit of work tomorrow. Everything should be working. Okay, let's Um, all right. Well, I'm sure this won't take all tomorrow to do, but we'll definitely start there. If we have time, I think I've got another little project I'm working on. I'll probably just work on that. It's more of a UI testing kind of thing, or UI testing my knowledge of how UI stuff works is probably more accurate. Okay, so thanks for joining. Next time is tomorrow, Tuesday, 1 to 3:30 p.m. Eastern Time, or 6 to 8:30 p.m. UTC. Have a good evening. Bye-bye.